Welcome to recording 1B in our series on quadratic functions in Vertex form for Unit 3, Chapter 3 of Quadratic Functions, Mathematics 2200. We'll be focusing on graphing functions of the form y equals x squared plus q and y equals x minus p squared. We'll begin with y equals x squared plus q. Q is a number added or subtracted, really, or you could think of it as adding a negative at the end of the function. So in our first example here, our q value is 2. So q equals 2. Let's pay attention to that as we do some calculations. Y equals -3 squared plus 2. Well, that will give us 11 instead of the 9 that would have been on the base graph. -3 and 9 would have been the point there. So this point is actually 2 units higher than on the base graph. A little bit up off our scale, so I'll guesstimate the height of that one. Y equals -2 squared plus 2, which is 6. Again, that's 2 units higher than it would have been on the base graph. Y equals -1 squared plus 2, which will give us 3. And that's 2 units higher than it would have been on the base graph. On the base graph, it would have only been as high as 1. 0 squared. Well, let's see. 0, 0 was the vertex on the base graph. 0, 0 becomes 0, 2. It's 2 units higher. Let's go with 1 squared. 1 squared would be 1, so we would have had a point at 1, 1 on the base graph. Now it's going to be at 1, 3. And similarly, if we put in the 2, we get 6 here, and if we put in the 3, we get 11 again. So I've plotted the remaining points, and I've traced over the base graph y equals x squared. To get that graph to fit the points that I've plotted, I've got to slide it or translate it up 2 units, allowing for a little bit of roughness in my drawing. So I've plotted my points, I've translated my graph, and I've written in the information necessary here. The axis of symmetry, you notice, hasn't changed from the base graph. Likewise, if I complete the table for this second graph, because there's a Sec.3 at the end, I end up decreasing all my y values by 3 compared to the base graph. So plotting those points and tracing at the base graph again, all I need to do is translate it down 3 units to fit over the plotted points. So our vertex is now at 0, -3 instead of 0, 0. The q value, if you focus on that, is at -3. So for y equals x squared plus q, all we need to do is, to get the vertex, is say that the vertex is at 0 and the q value. Over to our next type, y equals x minus p squared. This time we're going to subtract the number from whatever x value we put in and then square. Notice though, I have put in the y values for my table this time instead of my x values. Let's see why I've done that. Remember on the base graph, 0, 0 is our vertex. So we're going to start in the middle of our table and we're going to predict the x value we need over here so that we get a y value of 0 here. So what number subtract 4 will give me 0, because I need to square 0 in order to get 0. And the answer for that obviously is 4. 4 minus 4 would be 0. So I must have started with an x value of 4. Likewise, on the base graph, I would have had a point at 1, 1. So if I put in x is 1, I would have got 1 for the y value. Well, what number subtract 4 will give me 1? inside these brackets because I got to square 1 to get 1. The answer to that is 5, so I must have started with a 5. Likewise, I must have started with a 6 in order to get 6 minus 4, which is 2, and squaring 2 gives me the 4 that I need. If I start with 7 here, I get 7 minus 4 squared. That's 3 squared is 9. So all my x values are 4 greater than they would have been in the original table. So for example, 3 minus 4 would be negative 1. So in y equals x squared, I would have just substituted in negative 1. Now I've got to substitute in 3 in order to get negative 1 here. Square it, and I get 1. 2 minus 4 is negative 2. Square it gives me 4, etc. Plotting the points and tracing over my base graph again. All I need to do with that base graph is slide it 4 units to the right. So it does the opposite of what you would expect. You see a minus 4 here, you'd think it would slide to the left. No, it slides to the right because we have to increase all of our x values by 4 to compensate for that subtracting 4. So y equals x minus 4 squared. The vertex is at 4, 0, translates 4 units to the right. Notice that the value of p in our function is 4, not negative 4. It's the opposite sign of what you see there. The axis of symmetry has also moved to x equals 4. In this second example, we have to put in negative 3 in order to get a 0 in this bracket for squaring. So we have to compensate for the adding 3 by decreasing everything by 3 for the x values. So completing the rest of the table, sketching the graph, we see that the graph has shifted 3 units to the left with a vertex of negative 3 and 0. So we take the opposite sign of what's in the brackets for our p-value. To conclude, the graph of y equals x squared plus q has vertex at 0, q. The graph of y equals x minus pl squared has vertex at p and 0. And that one changes the axis of symmetry to x equals the p-value.